So we have finished previous topic what we have learned Newton's first law, second law and third law. Now today we are going to start inertial and non-inertial frame, what is rest and motion. After this we will solve enormous question, okay, n number of problems we will solve. Different models, different varieties of problem we will solve so that you have good clarity regarding the concept, okay. Now write down the
Yes.
heading, frame of reference. Today we are going to learn this topic, frame of reference. Frame of reference. Frame of reference. Before understanding the frame of reference, write down the definition of rest and motion. What is rest? Write down. Position does not change with space and surround with space and time. Position. You can write the definition of rest. Position does not change. does not does not change with space and time. Clear? Next is write down motion. Motion means position does change with time and surrounding. Okay.
Yes, sir.
Position does change with space and space and time. Space
Right.
means surrounding. Okay.
Yes, sir.
Now moving to the next topic, frame of now today. This topic really very important. Like again, I will highlight this topic, frame of reference. So frame of reference means write down frame of reference. Frame of reference is the name of an observer. Is the name of an observer. Okay. Name of an observer. Name of an observer. Clear?
Yes, sir.
Frame of reference is the name of an observer. To stop. After this, write down if if frame is not given, if frame is not given, if frame is not given, then assume observer is standing on the ground. Observer is standing on the ground. Observer is standing on the ground. Okay. Oh, not what happened. Okay. So you just write some points. Okay, then I will discuss. Write on. If velocity of if velocities of two observer if velocity of two observer are same in magnitude and direction, clear?
Yes, sir.
If the velocity of two observer are same in magnitude and direction, then their frame of reference becomes equal. Then their frame of reference if velocity of two observer are same in magnitude and direction, then their frame of reference becomes equal. Okay. After this, write down force, time, and mass does not force, mass, and time do not depend on frame of reference. Clear? Do not depend on frame of reference. Clear?
Yes, sir.
So frame means, for example, if you are going to your school, okay, from your home, then you are the what your mother is the observer. Clear? Understood?
Yes,
So
sir.
frame, you can say it is a place where observer is standing. You can say like that. If I'm sitting in this room, my frame is this room only. If I am looking some motion, for example, one moving train is there and I am the observer, I am looking the passenger in the moving train. Then my frame is, I can say the velocity of the state of those passenger in the train with respect to me. Motion, clear? Or I
Yes,
can
sir.
say with respect to my room, clear? So frame simply means what? It is a location where observer is standing. That's simple. Clear? Or you can say it is a name of an observer. Frame of reference is a name of an observer. If nothing is given, always take ground. Third, a velocity of two not object, observer. They are same. Then we can say their frame is equal. Clear? For example, two
Yes.
passengers are in the same train. Clear? Then they are feeling both are at rest with respect to each other. Why? Because their frame is moving with the same velocity. Their frame is same. That is why their velocity are same in magnitude and direction. Clear? So
Yes.
again, I will explain this. Same thing. I think I have explained before also, not, but I just want to explain. For example, this is a moving train. In this moving train, this train is going to move with a velocity of 100 kilometer per hour. And some passengers are standing on the platform. Okay. On the platform, some person are standing like this. This is person C. And inside the train, two passengers are sitting like this. He is A and he is B. Clear?
Yes,
Now
sir.
see. 1 minute. Yes. Now look at this. If I ask like what is the velocity of A with respect to observer B? If I am saying velocity of A with respect to observer B,
0.
why it is 0? Because for A, frame is moving train. For B, moving train. If the frame of reference is equal, then velocity is also equal in magnitude and
Equal.
direction. That is why for both A and B, their frame of reference is equal. Clear? That's why their velocity of two observer will be same in magnitude and direction. So if I ask velocity of A with respect to B, it will be 0. So what is the meaning of this term? Velocity of A, velocity of A with respect to B. Clear? One
Yes,
more
sir.
meaning is that, or velocity of A, velocity of A as seen by B, as seen by B. It is, meaning is clear? So
Yes, sir.
velocity of A as seen by B. So A is the object and B is the observer. Now if I ask second question, what is the velocity of B with respect to A? Velocity of B as seen by A. If you are sitting
Again,
in
0.
the train itself, then your fellow passenger will be at rest. Clear?
Yes, sir.
Rest. It is also rest. Okay. But if I ask like, what is the velocity of A as seen by C? If C is looking A, then according to C, what is the velocity of A?
100 kilometers per hour.
100 kilometer per hour. Very good. 100 kilometer per hour. Now why? According to C, A is in motion. According to B, A is at rest. Why? Because they have different frame. That's why they are
Same,
giving
sir.
different answer. For C, its frame is platform. Clear? So frame clear. Frame of reference is the, either you can say is the name of a location where observer is standing. Second, or you can say it is the name of an observer. I am saying here velocity of A with respect to C. Clear? Now C,
Yes,
observer C is standing where? On platform.
sir.
So I can say velocity of A with respect to platform also 100. Meaning is that same because they are, C is standing on the platform. Clear? So we can say velocity of A with respect to C is 100 kilometer per hour, or I can say velocity of A with respect to platform is also 100 kilometer per hour. Meaning is clear?
Yes, sir. It's clear.
Any doubt?
No doubt, sir.
So frame means simply it is a name of an observer. Simple. If I am saying velocity of block with respect to trolley, so trolley is a frame. Clear? So frame, if
Yes,
frame
sir.
is not given, always take on observer is where? On the ground. Assume. In most of the question, like they will give you frame. But in certain question, if they are not giving frame, then always consider observer is
Grounded.
standing on the Where?
Ground.
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 Clear?
Yes, sir.
If velocity of two observers are same in magnitude and direction, then their frame of reference
Same.
is equal.
Same.
For A and B, their velocity is same in magnitude and
Same.
direction. That's why their frame is equal. Clear?
Yes,
Now
sir.
you tell me, this is one car. Okay, one car. Here driver is sitting. One more car is here. Let us suppose there are two cars. And both the cars are moving with the same velocity. For example, 100 km per hour. Here also 100 km per hour. Now the driver of, this is driver of here. Driver of car is driving this car. Let us suppose A. Here driver of car, this car is B. Now you please tell me, if A is looking B, if A is looking B, then velocity of B with respect to A will be what?
0.
Very good. Because both are moving the same velocity. They are very close. They are very close and they are going like this. Okay. They are going very, very close. Understood?
Yes, sir.
Then they will feel that this driver is at rest. He is not moving. If he is not looking outside, the passenger in the car A feel that car B is at rest. It is not moving. If they are not looking outside. Clear? Passenger
Yes.
from car A can be easily transferred to car A. Passenger of car A, car B is also easily transferred to A, and simultaneously from A to B and B to A, they can exchange. Sometimes you have seen like person, two person are moving on the bike. This is one bike, second bike, and they are moving like that, same velocity. This person move from his bike to next bike. Okay, so they can exchange their position only when they are moving. Their frame of reference is what? It comes equal. Clear? Understood?
Yes.
So velocity, if velocity of two observer are same in magnitude and direction, then their frame of reference is also equal. We can consider it is equal. Force, time and mass does not depends on frame of reference. Clear?
Yes, sir.
Understood?
Yes, sir. Understood.
Now there are two types of frame. One is inertial frame, one is non-inertial frame. Write down types of frame. Types of frame. First is inertial frame. Inertial frame. Clear?
Yes, sir.
Now what is inertial frame? Inertial frame is a frame which is non-accelerating. Okay. We are
Yes.
considering our earth to be at inertial frame. Why?
It doesn't accelerate.
Why? Because the angular velocity of the earth, the rotation speed of the earth is very, very small. Almost negligible, but it has certain velocity. So we can assume. Clear? So you can write it is a
Yes.
frame. In inertial frame is a frame where Newton's law are valid. Write down it is a frame It is a frame in which Newton's law of motion are valid. Newton's law of motion are valid or applicable. Okay.
Yes, sir.
By an experiment, by an experiment, Earth is an approximate. I'm not saying inertial, okay? It is approximate. We are saying Earth is an approximate because we are living on the Earth. That's why we are thinking Earth is at rest, but it is not. Approximately, we are considering, okay? Earth is an approximate inertial frame, okay? Clear? If we
Sir, why
neglect,
are you saying it is an approximate inertial frame? It doesn't have acceleration, it only has velocity, right? So,
yes, that's what, that's right. If we neglect, if we neglect rotation and revolution of Earth, rotation and revolution of Earth, okay? Clear? If you
yes, sir.
neglect rotation and revolution of the Earth, then we can say Earth is at approximate inertial frame. Clear? What is the, you tell me, how much time Earth takes to move Earth's rotation? Sense of rotation of the Earth is from west to east, like this,
Yes, sir.
okay? Like this, okay? So angular velocity, omega is what? Theta by t. In time period, how much time period? 24 hours. Earth is going to rotate how much? 2 pi
24 hours.
360. Just put the value in SI. 1 hour 60 minute. 2 pi. How much? 36 to the. This is rotation speed. But if you ask me like what is the revolution? Clear? Rotation. In revolution, you how much?
365 1 by 4 days.
In revolution, this time will be 365 days. Okay. 1 day 24
Yes,
hour.
sir.
Clear?
Yes, sir.
This is what? Clear? Revolution. Now, if you find these values, this omega is approximately tending to 0. I'm not saying completely 0, but it is very, very small. Clear? Very, very
Yes, sir.
small. Very, very small. That is why only we are considering Earth to be at approximate inertial frame. It is not. Very, very slowly. You can't observe its motion that much. Okay?
Yes, sir.
Clear?
Yes, sir.
So Earth, Newton, according to what Newton did, he told like with respect to Earth, if object is accelerating, if a person is standing on the ground, for example, you are in your room, and if you are looking outside the moving train, That is accelerating frame. Clear? So
Yes, sir.
definition of inertial and non-inertial frame. Always we say this frame is non-inertial always with respect to inertial frame. Because in inertial frame, whatever you are going to say, that is correct. Newton's law is valid in inertial frame. Clear?
Yes, sir.
Understood? Any doubt?
No doubt, sir.
Okay. Now moving to the next important point, write down. Important note. If a frame, if a frame becomes inertial frame, inertial frame, a frame becomes inertial frame if it does not accelerate as seen from the earth. Clear? A frame becomes inertial frame if it does not accelerate as seen from the earth. Clear?
Yes, sir.
Now moving to the non-inertial frame. Non-inertial frame. Non-inertial frame. Remember what I explained. Force, time, and mass does not depend on frame of reference. Clear? Three things. If you check in your watch to like 9 p.m., let us suppose, then even if you are going in non-inertial frame now, in that moving train also there is a 9 p.m. Clear? It will not change. Okay. Now if I ask one question, for example, this is a lift. Clear? And with the help of a string, one block is attached like this. And this lift is going up with acceleration a naught. Clear? Now my question is, there are two persons, one is standing on the ground. This is person, you can say observer B. Now according to this observer B, if I ask please draw the free body diagram, my target is to find the tension force. Because once you attach this block with a string, then string become tight. And if string become tight, then tension comes into play. Understood?
Yes, sir.
Any doubt?
No doubt, sir.
Now, if you look at carefully, if you draw the free body diagram, and remember, you are with respect to you are standing where? Ground. Ground is inertial frame. So whatever free diagram you are going to draw, that will be correct. Mg, up tension. Okay, understood? Now this
Yes,
is
sir.
going, if you apply Newton's law, how to find the tension force? Can I write like this? T minus mg, F is equal to m into A. Can I say?
No,
Is it
sir.
correct?
Yes, sir.
Net force is equal to mass into acceleration. If this lift is going up with a naught acceleration, then this block is also going up. Clear? Now, this A naught acceleration which I am telling, this A naught acceleration is with respect to whom? This person B. Clear? Now, but if I
Yes,
ask
sir.
like this person B, not person B, you can say person C. He is in the lift. Okay. Person C is here.
The,
Now, in this question, my question is that according to C, what is the free body diagram? You will draw like this. One is mg, tension. Okay, you will say like that. Now, my question is that when you are inside the lift, according to you, do you see this block is accelerating?
no, sir.
Only tell me. No. Very good. According to you, this block is at rest. Then what you will say? Tension is equal to mg. This block net acceleration will be 0. It is at rest. T is equal to mg. But here you are getting T is equal to mg plus a naught. Now who is correct? Tension will not be same because string is same. The same string is giving different result in the lift. The same string is giving result according to the person on the ground. So what's going on? What is wrong? The wrong is that there are two observer. One is standing on the ground. One is in the moving lift. They have different frame of reference. Clear?
Yes, sir.
Understood? So both
Yes, sir.
the observer B and C, they have different frame of reference. For observer B, it is ground. For observer C, it is lift. And lift is not a inertial frame. Why? How do you decide this lift is inertial or non-inertial? Note I have written.
It is accelerated.
If you are looking from the ground, frame means it is a location where observer is present. Now C is present where? In the lift. For C, either you can say C is a frame or lift is a frame. For C, clear? Now my question is, this moving lift is inertial or non-inertial? How do you decide? Now, if you're
It's
looking
not.
this this lift is going to accelerate A naught. Okay, understood? So if
Yes, sir. Understood.
a frame become inertial frame if it does not accelerate as seen from the earth. But if you're looking from the earth, means ground, this frame is going to accelerate. So it is a, first of all, it is a non-inertial frame. Non-inertial frame. In non-inertial frame, we can't apply Newton's law. So it is not correct. Understood? We can't apply
Yes.
Newton's law. That is why T never be T value of T. We are not getting the right value of T. Understood? But now my question is that if I want to apply Newton's law, if I want to apply Newton's law in this frame also, then how will I apply? How will I apply?
It is as seen by B.
So my question is, in the same frame, how will you apply? So I'm telling you one thing. There is a concept of pseudo force. Actually, pseudo force does not exist. We are using the concept of pseudo force to make Newton's law applicable in non-inertial frame. Clear? So if the observer is in the non-inertial frame, always use pseudo force to make Newton's law valid. That's only. Now you please tell me, if you look at both the diagram, carefully, here T is equal to mg plus a naught, here mg, only mg. There is a, what is lacking here in non-inertial frame? Mg plus ma naught. Ma naught is lacking na here.
Yes,
That side is wrong. So this ma naught we have adjust as a pseudo force. Okay.
yes,
This
sir.
ma naught actually we are saying pseudo force just to make others fool. Simply. Clear? But actually the pseudo force never exists. But to make Newton's law applicable, we are using this concept. Now see. So if a person in the lift, how will you apply the pseudo force? Like this, block M. Person is here. Okay. Now how will you apply? Simply draw the free body diagram. Mg will be like this. Tension will be like this. Pseudo force will be what? Mass of the object on which Newton's law is going to apply. So this is my object on which I am going to apply Newton's law. Multiply acceleration of observer as seen from the ground. Clear? And its
Yes, sir.
direction is opposite. Like this. Okay. This MA naught is what? Pseudo force. Pseudo force. Clear? Pseudo force, just write down here. Pseudo force is equal to M into A. What is M? M is the mass of body. Mass of body on which law is applied. Clear?
Yes, sir.
What is A? Write down
Acceleration of the
acceleration of observer. Very good. Acceleration of observer. Observer as seen from the earth. As seen from the earth. Clear? Acceleration of observer as seen from the earth. As seen from the earth means with respect to the observer standing on the ground. From the ground, always acceleration of a non-inertial frame, or you can say observer. This observer is whom? This observer is this. Okay, it's acceleration if you are looking from the ground. Then if lift is going up with a naught acceleration, then this observer is also going with a naught acceleration. Understood?
yes,
One more thing I just want to explain. Uh, this is clear, like direction, because acceleration is magnitude, am I not clear? But direction, write down direction. I'm writing here direction of pseudo force. Direction, write down opposite to acceleration of observer. Acceleration of observer. Okay. If this
yes,
observer is going up with a naught acceleration, then pseudo force will be like this. M a naught. Clear?
yes, sir.
Understood? Any doubt in today's lecture?
No, sir.
Little bit. I will ask some question. Quickly give me the answer. This is the object which is placed on this moving train, which is moving with a1 acceleration. Okay. According to observer B, apply pseudo force. What is the direction of pseudo force?
Left direction.
Very good. If I draw the free body diagram of this, it will be mg normal. A since it is going like in this direction. Very good.
MA.
Very good. M M object.
A1.
M is the mass of
A1.
an object on which law is going to apply. Multiply acceleration of observer. Clear? As seen from the ground. So observer is going in the right with A1 acceleration. Clear?
Yes, sir.
Clear? Any doubt?
Yes, sir. No, no
Now
doubt, sir.
tell me this question. If this is going with constant velocity, clear? And object is here. Now tell me, according to this observer D, what is the direction of pseudo force?
So no pseudo force.
Very good, because it is moving with constant velocity. Very nice. I'm really impressed. Super knowledge, yeah, super catching power. Really, I'm really impressed today with your understanding because it is moving constant velocity. There is no acceleration, no pseudo force. Very good. So if you draw the free body diagram, it will be mg and one is normal. Tell me, tell me. Observer
Right
C,
side.
block is this. Right? mg, clear? You tell me what is the direction of pseudo force?
MA2 in right side.
Very good. Clear?
Yes, sir.
Now conversion of frame I will discuss in the next class because don't worry, don't think like I'm starting in the next class because whatever topic I'm going to start in the next class that is really long. Within 10 minutes I can't finish. I have a
Yes, sir.
class at 7 o'clock. I need 10 minutes to assemble for next class. Okay,
Yes, sir.
don't worry. Slowly we are going, but one day you will realize entire mechanics will be on tips. My target is to make you clear each and everything regarding mechanics.
Yes, sir.
Dynamics, we are basically dealing with dynamics. Introduction to vector and forces. Forces inside forces, many things are here. Clear?
Yes,
After
sir.
understanding this, a lot of varieties of question, momentum question, impulse, lot of question we will solve. These concept will help you like inertial frame, non-inertial frame, and sometime you will understand like by considering our observer in the non-inertial frame problem is easy. Clear? And one thing like I just forget like wherever observer, for example, observer is standing on the ground. Clear? If I'm saying observer is standing on the ground, then draw x and y there only because according to him only I am telling which is positive, which is negative. Draw x and y there as well. So sometime like
Yes,
in some books they are writing system of coordinate axis is frame of reference. Either you can say it's a name of location where observer is present, system of
yes, sir.
coordinate axis, or you can say it is a name of an observer, frame of reference. Meaning is same. So wherever observer is there, with respect to whom you are telling everything, draw x and y. If I draw x and y like this, it is origin, right is positive, up is positive. Okay, like that. System of coordinate axis is also a frame of reference. Sometimes they will not show observer, they will show axis like x axis, y axis, like this. Then this is also system of coordinate axis. Coordinate axis simply this is frame of reference. Okay,
Yes, sir.
meaning is clear.
Yes, sir. Clear.
Okay, thank you so much for your time.
Thank you, sir.
Thank you.
Thank you, sir.